Hello, my name is Daniel, and in this tutorial I will show you how to build a basic car control rig inside Unreal Engine. First we will create some joints inside Cinema 4D, but you can use any other 3D application. Then I will show you how to export the file correctly out for Unreal Engine, and inside Unreal Engine I will show you how to import the file correctly, set up an animation blueprint, and how to build the final basic car control rig. We will create a drift control, chassis control, steering control, some controls to move the tires up and down, and a control to create the wheel rotation. Okay, let's start with creating some joints and binding the individual meshes to the joints. In my case I use Cinema 4D, but you can use any other 3D tool with which you are familiar with. In my case I trust Cinema 4D. Okay, first we have to mention some things when it comes to creating a skinned asset for Unreal Engine. It is of course important that you have as less materials as possible and as less individual meshes and geometry as possible. And of course, please name everything correctly, because later in Unreal Engine you want to switch the materials and it's very hard to figure out which material is assigned to which part if you don't know the correct name. So please name everything correctly. Okay, I think that's it. Here in my case I have 800,000 polygons for this car model, which is absolutely okay for Unreal Engine. And let's create some joints. So I simply jump into the characters menu, create a joint, and the first joint is always the root joint, which is very important for Unreal Engine. It sits in the center of our 3D space and nothing is related to this root joint. Then I copy this root joint and rename it to chassis joint, and maybe we put this chassis joint directly underneath the geometry of the car, something like that. Then let's select our both tires, the front tire and the back tire, and convert some joints out of them. Now we have this tire front left joint. We rename it to front because this is the joint for our front axis, and we put it in the center of our car, something like that. Then we have this tire back left joint, which we call back. It's a back axis joint, and we also put it in the center of our car. Wonderful. And I need these two joints for creating the drift behavior inside Unreal Engine, because later I want to create an IK for them. So we put the back joint underneath the front joint, put the package underneath the root joint, and then we put the chassis joint underneath our front joint. So everything gets rated to the chassis. Then we need some joints for our tire and for our brake, because if we rotate the tire, the brake doesn't rotate with the tire. So it's very important that you have at least two joints for the tire. So one joint for the brake, everything gets rated to this, and then one joint for the wheel. So all the wheel stuff gets rated to the wheel joint. But in my case, I use 3 joints because I also want to create a controller to move the tire up and down to get this nice suspension behavior. So let's create a joint for the tire here. I convert it, and then I have the tire front left joint. Whoops, front left, and I simply copy this joint, put it underneath, and I rename this one here to wheel front left, and the other one is named brake front left. And let's do that also for the other tires, and then I come back for rating or for skinning the individual measures to the joints. Okay, and now I have all my joints, and we put the tire packages underneath our front joint here. Something like that. Wonderful. And it should look like that. So that's our final hierarchy for the car rig. And let's create some rates for the individual measures. First of all, I want to rate the tire. So I simply select my tire here, which is called tire front left. So I choose the wheel front left joint, and I simply jump into the characters menu, choose the binds command, and then I get this rates tag and the skin object. And we simply double click the rates tag, and then we select all our points for the wheel. And then we jump into the manager, rates manager, and here we choose the absolute mode, 100% strength, and we apply the selected points to the joint. Wonderful. Now we have 100% rates for all the different vertices. Nice. We do that also with the brake. So let's select the brake front left and choose the brake front left joint. We simply jump into the binds menu, and then we simply apply selected. Wonderful. And now we are finished with rating our tire. So as you can see, now I can move my joint tire front left up and down to move the whole tire, but I can rotate my wheel front left joint, and the brakes rotates with it in this case, but later in Unreal Engine we are able to do not propagate the rates or the binding for the controls to the brake front left joint, and so it stands still. So it's very important that you have this brake front left joint for the brakes in your rig. And so I will rig all the other tires, or I will bind all the other tires, and of course all the chassis parts we bind to the chassis joint here. So back and front joint has no bindings, and also the root joint has no bindings. Okay, and that's it. Now I will bind everything, and then we are ready to export it for Unreal Engine. Okay, let's export this thing out, and in this case I use FBX format. It's the best format for me for Unreal Engine. I use it almost for everything. Let's click at this cogwheel here, so we get the export settings. We make sure we choose the latest format here, which is 7.7 2019, and then we make sure in my case to export the normals, because I have normal text here for the individual meshes. And of course I make sure materials is checked, and if you have textures you want to use inside Unreal Engine, you can simply check embed textures, but in my case I don't have any textures for it. So I only select material, and then we simply hit the OK button and save this thing somewhere on our hard drive, and we are ready to import it into Unreal Engine. Okay, now here inside Unreal Engine we make sure skeletal mesh is checked, import mesh is checked, and we also want to convert the scene into the Unreal Engine coordinates system, and we also force the front x-axis. So make sure both are checked, and then you're ready to go. You can simply import all into inside Unreal Engine. Okay, once you have imported your FBX file inside Unreal Engine, you will get this skeletal mesh asset, the physics asset, and the skeleton mesh asset. And we simply want to create a control rig out of the skeletal mesh asset. So let's create one, create control rig, and it is named car tutorial control rig, which is okay in this case. And of course we need an animation blueprint. Here, animation blueprint, right click, create animation blueprint, and it's called car tutorial skeletal animation blueprint, which is also okay in this case. Let's save them. Okay, wonderful. And now we have to assign the control rig to the animation blueprint. So let's open up the animation blueprint, and I simply put it here. And inside the animation blueprint, I search for the mesh space ref pose and simply connect it with the result port of my output pose. And then we simply place a new node out of the output port of the component to local node. And here we search for the control rig node. And inside the control rig node, we are able to assign our control rig class. So that's very important, that everything works perfectly for your animation inside Unreal Engine. So let's select the right control rig class. And here we want the car tutorial control rig. So let's compile this and save it. Wonderful, we don't have any errors, this should work. So now we are able to create our rig inside the car control rig blueprint. Okay, let's create our control rig behavior. So I simply double click at my control rig blueprint. And here inside this blueprint, I can see my 3D model in the upper left window. And as you can see, we have to compile it first. So if you create some new controls or do some new nodes, you always have to compile it. Simply hit this button here and you're good to go. In the lower left window, we see the rig hierarchy. And here, as you can see, all our bones appear. We have created inside Cinema 4D. We have some other tabs. This is the execution stack, and here you can see the execution behavior. So which events are executed, and you get this the list. If you create some new nodes, you will see the list extends further. Then we have a curve container. We don't work with it at the moment. And then we have the My Blueprints tab, and here you can create also some variables for your blueprint, functions or new graphs. But in this case, we mainly want to work with the rig hierarchy in this case. And first of all, I want to create my drift control. And for that, I simply select my backbone here, right click on it, and then we simply choose a new control here. And we put it outside the bones hierarchy. That's very important. We don't want to have any controls inside the bones hierarchy. So let's rename this controller to drift, because it's our drift control. As you can see, we have to recompile it. Simply click the green button here. And then for the drift control, because we can see it at the moment, we need a nice shape so our animators can access the control nice and easy inside the editor. So let's select the drift control, and here in the details panel we are able to select a nice shape. So let's search for a circle thick in this case, and then we can give it a nice color. In this case I choose a blue color for it, and of course we have to scale it. So let's try 30 for it in any direction. Wonderful. And maybe for the X direction I choose 10. So now I have this nice control here. Okay, that's my control. So let's put this control inside the source graph here. I want to get the control. And as I said, I want to create an IK behavior for it. So let's choose a simple or a basic IK solver here in this case, the basic IK node. And inside this node, I have to set up my item A, item B, and my effector item, which is in this case always a bone. So the first bone is my front bone. So I simply select my front bone. And as you can see, it's very important that you have named everything correctly. And for my item B, I choose my backbone. And my effector item is also the backbone. And the effector in this case is my controller. So I can simply connect the transform with the effector input port here of the basic IK. And we have to make sure that we have an item B length. And in this case, I try 1 first. Okay, and now we are good to go. We can simply execute this. So let's put the forward solve node execute output with the basic IK execute input. And as you can see, now the whole rig snaps like that. And that's because we have to define the correct primary axis. So let's expand this pin here. As you can see, now the primary axis is 1 in this case. But if we select the control, and as you can see here, we have the x-axis, and the front bone here points to the x-axis of this control in the negative direction. So our primary axis must be -1. So let's put in -1. And as you can see, this snaps here. Now it's rotated, and that's because we have to define the secondary axis, which is y in this case, and I put 0 inside. Let's move the controller, and I think that's it. That's the correct behavior for the rig. So as you can see, I can simply animate and drift with this controller. If you want to reset the controller back to its origin position, simply select it, and here you have the transform tab, and here we have the current animation transform, and here we can reset it back to its origin position. Or if you compile it, so I move the controller, you compile it, and it resets back. Okay, wonderful. That's the control for our drift behavior. Let's create a control for our chassis. Okay, let's create the control for the chassis. Simply right click at the chassis bone and then create a new control. And of course, we also drag and drop it out of the bones hierarchy, rename this to chassis. Wonderful, and recompile everything. And let's give this chassis control a nice shape. And in this case, I want to use an arrow for thick, a yellow color, maybe something like that. And then let's scale it 20 by 20 by 20. And as you can see, the control is not easy accessible for our animators, so we have to offset the control, but we want to stick to the same coordinates as our chassis bone. And for that, we have an built-in offset transform here. So let's select this offset transform, and we have to move the C axis up. So let's put in maybe 130. Wonderful. And now our control is easy accessible for our animators, but it uses the same coordinates as our chassis bone. And let's create the behavior for it. So if I move my controller here in the X direction and in the Y direction, I want to rotate my chassis bone. So let's do that. Simply drag and drop the chassis controller inside the graph, get the control, and then we want to set the bone, the chassis bone here. So let's set the bone. And we always make sure if we rig something, we work in local space. So let's select the local space for it. And we want to rotate the bone. And as you can see here, we have the rotation input, but we don't have access to the different axes as we have with the translation axis. And for that, we need another node. So let's drag this pin out and search for an from Euler node. This one here. And with this Euler node, we are able to access the different rotation axes. Wonderful. Let's put this node here. Let's put this here, and let's put this here. So if I move my X axis, I want to rotate the Y axis of my bone. Nothing happens, and that's because we have to execute it. You can execute it after the basic IK by wiring this output here together with this input, or you make everything nice and clean with a sequence node. So let's search for a sequence node, and with the sequence node we are able to execute our nodes without wiring them together. So let's simply wire the A output with the basic IK and wire the B output with the set transform bone. As you can see, it snaps something like that because this is the global space and we have to put in the correct translation for it. So let's disconnect the wiring and search for the chassis bone here. And as you can see, it has the wrong coordinates. So I have to put in the correct coordinates here for X and for C. So I have selected my chassis bone, and here I simply copy the coordinates and put it inside the translation of my transform bone. And now I'm able to wire it together. And as you can see, nothing happens. It's nice and clean. And if I move my control, you will see the whole chassis rotates. That's very nice. Let's connect the Y axis with the X axis of my bone. And as you can see, it rotates, but in the different way. So we have to negate this output. So simply drag the pin and search for a negate node, and then rewire this here with the x-axis. And as you can see, now we have the correct behavior for it. Wonderful. And I also want to move my control at the z-axis, and I want to connect it with the translation of the z-axis of my bone, so I can animate a suspension behavior for it. So let's do that. As you can see, we have in the z-axis some coordinates, so we have to copy them out and we have to add them with an math add node. So let's connect the z-axis with the A input port, and then we simply paste in the coordinates of the z-axis from the bone, and then we simply wire the result with the z translation axis of the bone. Nice. Recompile it, and as you can see, now I can move my chassis up and down. Wonderful. I think that's the chassis control behavior here. And the next thing is we want to create some controls for the tires. And you can also double click on a line to get this reroute node here. So you can simply make it nice and clean here inside the nodes graph. Looks very nice and clean. So I want to work not from left to right. I want to work from top to bottom. Okay, let's create a steering control for our front tires. So we have to set the rotation of our front tires. Simply choose the wheel front and wheel front left. Wheel front right and wheel front left, yes, and drag and drop them into your source graph, and we want to set the rotation. So only the rotation, because we rotate the wheel with our wheels rotation controller, which we will create later, and we rotate the wheel with our steering controller. So no transform, no translation for this bone, only rotation. So I only set the rotation for the bones, and let's move this here, and let's connect the pins together. And then we have to create a new control, and I create this control out of my front bone. So let's right click it, new control, move it outside the bones hierarchy, and rename this control steering. Wonderful. Recompile everything. And of course we have to offset this control because it's very hard to select it. So let's offset it, maybe 100, something like that. That's nice. And give it a nice shape, maybe a sphere here, sphere thick. And let's scale it 3 by 3 by 3. And also we choose another color, maybe something like that. Wonderful. Let's get this control here. So get control. And we also make sure we work in a local space. So let's choose a local space here, and here also a local space. And then we need the rotation, because if I rotate my steering controller, I want to rotate my tires, and that's the Z-axis. So let's drag and drop this pin out, and we need another node which is called to Euler. So we get all the different rotation axes. So as you can see here, let's move this a little bit, something like that. And then we have to set the axis here of the rotation bones. We cannot connect it directly because we also need an node which is called from Euler. So we can set the different rotation axes. And in this case, it's C. So let's connect the C output with the C input. Wonderful. And we can simply connect the result directly with the second bone value. Wonderful. Let's move this a little bit so it's nice and clean. And I simply move it directly underneath my set transform chassis bone. Wonderful. And all we have to do, we have to connect the input execution pin here with our sequence. So let's create a new pin for it. Let's recompile everything and let's connect the C pin with the execute of the first bone here. Wonderful. Let's double click the line and create a new reroute node. So maybe something like this. Wonderful. Now it's nice and clean. And as you can see, if I rotate my steering control, the tires rotate. That's nice. Yeah, the rotation works. Wonderful. Let's reset the controller back. So we make sure we choose current, then reset everything back. Wonderful. Okay, that's nice. And now we want to create the real rotation. Okay, let's create a control here. And I create this control out of my chassis bone here. So let's right click it, new control. And let's drag and drop it out of the bones hierarchy and rename this control to real rotation, or we rename it to reals rotation. Let's compile it, and of course we need to create an offset for this control, so let's move it up maybe 150. Okay, nice. And for this control I want to change my value type. We have the possibility to change the value type here. We always used Euler transform here for our drift, chassis and steering control. And in this case, I want to use a float value type. And here you can change the primary axis, which is in this case X, which is nice because if I move it in the X direction, I want to rotate my wheels. And of course we need a negative direction, which is currently not available because we want to rotate our tires backwards. So let's set this up. So as you can see here in the values tab, we have a minimum and maximum. The maximum is currently 100, which is nice. And the minimum is currently 0, but we put in minus 100. And now, as you can see, if we take a closer look to the draw limits, we have this possibility to move it into the negative direction, a negative X direction. And as you can see, we get negative values. That's nice. We need this. So let's reset this back to 0. And of course, make sure you draw the limits. So you see this nice line here. And of course, you can choose another axis if you want. But I think in this case, X is the correct axis. Let's give this controller a nice shape. So let's search for arrow too thick. Wonderful. And maybe we have to scale it a little bit. So let's put in 3 by 3 by 3. Nice. And let's rotate it. So 90 degrees X and 90 degrees Y. That's nice. Okay, let's get this control here. So let's drag and drop it into the source graph and get the control. Nice, and as you can see here, we have this float value with which we want to work. So first of all, I need a multiply node. So let's search for this multiply node. Then we need another multiply node, and we simply connect the result with the A input. And then we need a node which is called half pi for the wheels rotation. And then we need another node which is called accumulate time. So let's search for it. Accumulated time. That's our correct node. And now we are able to use the time output for our rotation. So first of all, we want to recompile it, and let's put the value of this time node here inside the Y rotation axis. So let's do that, connect it, and as you can see, if I move this, maybe we scale it a little bit further, 5 by 5 by 5. If I move it into the positive X direction, my tire begins to rotate. And that's the maximum value here, 100. And we can change the speed with the first multiply node here. So if I put a higher number inside this multiply node, maybe 10, you will see the tire rotates faster. So you have to try which value is nice for you. Maybe I choose a value of 20 here. So that's the maximum tire rotation. And as you can see, if I move it into the negative direction, my tire rotates backwards. That's nice. So we have the correct setup for this. And we have to also rotate the back tires, the rear tires. So let's reset the controller back and put in the wheel back right and wheel back left. And here we want to also set the rotation of the bones. That's nice. So let's connect the second bone with the third bone and the third with the fourth bone. And we make sure we use a local space here. And then we don't want to use this node here because here we create the steering rotation, and we don't want to have the steering rotation for our back tires, for our rear tires. So we have to create another from Euler node. Let's copy this node here and put in the time value here to the Y axis. Nice. And let's connect the result here with our back wheel bones. Let's recompile it and let's try it out. And as you can see, that's rotating correctly. Wonderful. But as you can see, the brake rotates with it. As you can see, we have created an extra bone here for our brakes. And now we don't want to propagate this rotation to our children. So let's uncheck the boxes here. And as you can see, if I move my wheel rotation controller, the brakes don't rotate with the wheels anymore, which is very nice. So therefore we have created this extra bone here, and we rated the brakes to this extra brake bone. Okay, nice. Let's reset the controller back and let's try the steering here. So let's rotate it. And as you can see, now we have a wrong rotation behavior for our wheels. And that's because of the rotation order here in our from Euler node. So let's change the rotation order for our front wheels to X, Y, Z. And as you can see, now we have the correct behavior for the steering and also for our wheel rotation. So it's very simple. We just change the rotation order and everything works fine. So let's recompile it to reset everything back. And then we have to create some parent nodes, because if I rotate my steering controller here, you will see that brakes don't follow anymore. So we have to parent the brakes to something, and we will do that now. Okay, we need a parent node in this case here. So right click and search for parent constraint. And inside this parent constraint node, we need to set up our child, which is in this case the brake front right. So let's select the brake front right, and then we simply click at this little button here, use item selected, to put it directly into the names field. So that's another method how you can put in your name. We worked with the list here, but you can also select it and then click this button. So then we have to set up our parent, and for that we simply expand the 0 pin here, and there we can set our item, which is in this case is also the bone, which is our wheel front right bone. So let's put this one in, and then we have the filters, and with these filters we are able to exclude some axes. And in this case, as you can remember, we use the Y wheel axis for the rotation. So let's exclude the Y axis here. And that's it. Now we have to connect everything. So let's connect this one to a new sequence pin, which in this case is the D pin. And let's connect this with the parent constraint, and maybe we create some reroute node here. So something like that. And let's try this one out here. So if I move my steering control, the brake rotates with the steering, so with the tire. That's very nice. And now if I move my wheels rotation controller, as you can see, the brake stands still, which is very nice because we used the rotation filter here. So if I check the y-axis, as you can see, now the brake rotates with it, and if I uncheck it, the brake rotates not with the tire. So let's recompile everything to reset everything back, and we do that also for our left tire here. So simply copy this parent constraint here, connect the execute ports together, and then we we have to choose the brake front left, and we have to choose the wheel front left. So that's it. So let's try it out. Simply rotate the steering control here. The brake rotates with it, and then we move our wheel rotation. That's nice. Okay, let's set up the controls to move our tires up and down to create some suspension behavior in our animation. So let's search for the tire front right and right click, create a new control here and move it outside the bones hierarchy. And we simply rename this to move tire. Wonderful. And I also want to create some nice color for it, maybe yellow, and a nice shape. We use an arrow to thick and we scale it maybe 5 by 5 by 5. And we also want to rotate the x-axis here 90 degrees. And we give it a nice offset, y direction, maybe 100, maybe something like that. That's nice. Wonderful. Let's recompile it, and then we simply need to parent the whole tire bone to the control, and we can do that also with some parent constraints. So let's create a new parent constraint, and we simply execute it after the brake parent constraints. And here we want to parent our bone to our controller. So let's search for the tire front right bone. I simply select it and put it in. So here I have the tire front right bone for my child. And then for my parent, I simply select the type, which is in this case control. And here I have my move tire control. So I simply put it inside this field here. And I only want to move my tire with the C axis up and down. So I simply choose as filter only C. So let's uncheck Y, uncheck X. We don't want to have any rotation. So let's uncheck all the boxes here for rotation. And that's it. So as you can see now, if I move my control up and down, I move the whole wheel with it. And let's check our steering control if everything works correctly. Yes, that's nice. So we have the correct behavior here. So we can steer our wheel and we can move it up and down, and we don't have any misbehavior. Let's try the wheel rotation control. And as you can see, this works also nice. Okay, let's reset everything back. And then I create the controls for the back tires and also for the left front tire. Now we have all the controls for our rig here, but we need to fix one thing. So if I move my drift controller, you will see all the controls don't move with the drift controller. So we have to fix this. So let's reset the drift controller back and create a new null object out of the chassis bone. New null object. And we put this null object below the drift controller. Let's rename this null object to orient chassis and recompile everything. And then we put all the controllers except the drift controller underneath the orient chassis null object. Something like that. And then we need another parent constraint because we want to constrain the orient chassis null object to the chassis bone. So let's create another parent constraint for it. So parent constraint, and here we search for type null, and we simply select it and paste it, and then we search for the bone, which is the chassis bone in this case, and we paste it in. Okay, now I want to execute the parent constraint before all the different controllers except the drift controller. So let's put it here in our node graph after the IK. So let's select everything except the IK and move it down. Maybe something like that. And then we move this parent constraint here. And now we can simply rewire everything of our sequence node. So that's very comfortable. Simply hold Shift and rewire everything. And we said we want to execute it after the basic IK. So let's put it here together with the B execution of the sequence node. Something like that. Wonderful. And this should work. So let's select the drift controller again, move it around, and as you can see now everything follows, which is great. Wonderful. Okay, let's reset the drift controller back, and that's our car rig here for Unreal Engine, but we can also limit the controls. So we have the drift controller here, let's select it, and then we are able to limit minimum and maximum for the location. So we only want to move it in Y and Z direction, so we can limit the X direction. So for X, 0 minimum and 0 maximum. We don't want any rotation, so we can limit this also. Wonderful. Okay, now we can move it at the Y direction, Z direction, but X is locked, and also the rotation for this control is locked. Wonderful. Let's reset it back, and so we can do that for all the other controls. We simply limit it with the minimum and maximum amount here of the transform tab. Okay, I will do that, and then we are finished with our rig. And in another tutorial I will show you how to animate this rig. Thanks for watching this video. See you soon and goodbye.